Today we will examine the photosynthetic activity of the Swiss chard extract and the effect of varying light intensity on the photosynthetic activity. First of all, we have to prepare the light box. This is the light source, and this is the box where the test tube will be situated in. In order to prepare the light box, first of all, you plug the light source into the source, attach the light box onto the box. In the back, there's a toggle switch to turn it on. At this moment, you should see the light. In the dial, turn it all the way to the maximum light intensity. And this would be the setting you have constantly throughout all the series in this experiment. On the top of the light source, there will be a full intensity of each light source itself. For example, for this one, it is 457. Record this number down into table 1 in your lab manual. From this moment on, that would be your full light intensity at 100%. From there, you can mathematically calculate the rest of the light intensity accordingly. And you can fill out table 1. Now with the light source properly set up, we are ready to set up the experiment to determine the standard illumination time. For this experiment, we need 2 test tubes, one for the blank and one for the time course experiment. In the blank, you want to add 1 ml of buffer, $3 ml of distilled water, and 0.25 ml of the thylakoid solutions. The thylakoid solution will be stored in the thermos on ice, away from the light source. Make sure you only take it out when you need it and replace that back into the thermos immediately. Give that a quick swirl for the solution to maintain its homogeneous nature. Add 0.25 ml of the solution into the blank. With a small piece of paraffin, quickly invert it to fully mix the blank. Keep in mind that with your blank, it should be green in color because there's no DCIP in the solution. Place 1 filter paper into the slot. And blank your sample at the wavelength of 620 nanometer in the spectrophotometer. For the sample that is ready for the time course experiment, similarly, add in 1 ml of the buffer, $3 ml of distilled water, here you want to add 1 ml of DCIP, which is in blue, and 0.25 ml of the thylakoid solution. Again, give the solution a quick mix. Mix well with a piece of paraffin. At that moment, you want to put your sample into the spec machine. And that would be your reading at time 0. Record down in the table in your lab manual. Place that in the slot and illuminate your sample for 1 minute. When the 1 minute has elapsed, put your same sample into the spectrophotometer, and that would be the time 1. Once again, repeat the experiment by illuminate your sample once again in 1 minute under the light box. Similarly, record your values of absorbance again in the table provided in your lab manual. Repeat the procedure until the absorbance reduce to 0 or almost to 0. From that moment on, you can plot all the data into the graphing paper provided in your lab manual, with the x-axis being the time in minutes and the y-axis being the absorbance at 620 nanometer. The standard illumination time is defined as the time it takes for your sample to reduce its absorbance about half to 2/3. From the graph, you can deduce the standard illumination time. And with that determination of the standard illumination time, that number will remain the time that you illuminate your sample throughout the rest of the series of the experiment. For this demonstration, the standard illumination time is 1 minute.